Hello students, welcome to the learning platform of Paritran classes. Today we are going to discuss work energy theorem. So let's start. Outline of this class is what? First we will discuss prerequisite of work energy theorem. It means what you have to know to understand work energy theorem. Second thing, we will discuss the basic of work energy theorem, especially for constant force, what is inside, how the work energy theorem works when force is constant. Then we will discuss the important point related to work energy theorem. In this section we will discuss which point we have to keep in mind while solving questions of work energy theorem. Next we will discuss problem based on work energy theorem, and here we will consider force is constant. Next we will discuss work energy theorem when force is variable, and this variable force will be depend on either distance or will depend on time. Next we will discuss work energy theorem problems based on variable force. Here we will solve two examples. In one, force will vary according to distance and in displacement, and in second, force will vary according to time. Okay, so let's start. Prerequisite of work energy theorem: you have to understand basic principle and basic theory of work done, when we can say work has been done. Okay, and also we have to understand when the work done is positive, when the angle between displacement and force is between 0 to 90 degree, the work done will be positive. At 90 degree, work done will be negative, and in between 90 degree to 180 degree, work done will be negative. At 90 degree, work done will be 0. Next, you have to understand Newton's second law. It means the basic of force. Third, you have to understand kinetic energy, and you have to understand potential energy as well as conservative force. Then only if you know these all points, then you can understand work energy theorem properly. Okay. Now start. Work energy theorem states that the net work done by all forces on a particle equal to change in its kinetic energy. Means if we will do some work on a particle, this work done will be equal to change in kinetic energy of the particle. So we will derive the same statement with the help of mathematical calculation. So we know that work done is equal to what? Force into displacement into cos theta, where theta is what? Angle between force and displacement. In this condition, we will consider theta is equal to what? 0. In that case, cos 0 is 1. So work done, we can write force into displacement, right? Force we can also write what? We know that F is equal to m into a. From where it came? It came from Newton's second law. So now we can write W is equal to ma into s, where s is what? Displacement, m is mass of the object, a is acceleration of the object. Now if you remember third equation of motion, that is v square minus u square is equal to twice a s, where v is what? Final velocity, u is initial velocity, a is acceleration, and s is displacement. And obviously this equation is valid for constant acceleration. So from here we can write s is equal to v square minus u square divided by 2 into a. So from here value of s we can put in this equation. So now we will get w is equal to what? M into a into v square minus u square divided by 2 into a. A will get cancelled out and it will left m v square minus u square divided by 2. Now again we can write the same expression, half m v square minus half m u square. Now see, half mv square is what? Final kinetic energy. We can write KEF, and half mu square will be what? Initial kinetic energy. So we can write KEI. And this will be equal to what? Work done on the object. So from this derivation, we got what? Work done on the object is equal to change in its kinetic energy. Right? I hope you understood this expression. Take a pause and try to understand once again if you miss something. Okay? Now move to the next point. Yeah, we understood work energy theorem, but while solving some questions, we have to keep some important point in our mind. The first point is what? Okay, work energy theorem you can apply for point object as well as extended object. But in case of rigid body or particle motion, you have to keep in mind one thing. Is the work done on object is changing shape of object, and if work done on object is also changing shape of the object, at that time we cannot apply directly work done on object is equal to change in its kinetic energy, because when the shape of object will get deformed, in that case some energy might be get stored in terms of potential energy also in the object. Okay, and some energy we have to invest in shape change. In that case, work on the object will be equal to change in kinetic energy plus work done in changing the shape of object, right? Second thing we have to keep in mind, what? Reference frame. If we are calculating work done on object from a non-inertial frame of reference, at that time work done by pseudo force also you have to keep in mind. So suppose there is an object on a wedge and you are applying force, suppose F, and object got displaced by X, and you are observing this motion with moving acceleration A. In that case, your frame of reference is what? Non-inertial frame of reference. And from calculating from non-inertial frame of reference, you have to consider work done by pseudo force also. In later numerical, we will consider this example also. The third one, we have to consider work done by all forces, right? Suppose you are moving an object on floor and applying force in this direction, an object also moving in this direction, and there is a friction force also Fr, suppose in this direction. In this case, work done by you will change kinetic energy of object plus also some work you have to do against friction, right? So in this case, third case, work done by you is equal to what? Change in kinetic energy of object plus work against friction, right? You have to consider. Understood? So you have to keep these all point in mind. Even in cricket, when the batsman is hitting the ball, all work done by the batsman is not getting converted into kinetic energy of ball. Why? Because you can hear the sound also of that bat and ball, so some energy get converted in form of sound energy. Some heat also will get produced between bat and ball, so some energy will get converted in form of heat, and then rest energy will get converted into kinetic energy of ball. Okay, so such all thing you have to keep in mind ki how the actually energy conservation going on, and when no other form of energy getting converted, at that time work done by you will get converted into kinetic energy completely. Understood? Now come back to the numerical. So here the question is what? In Mission Impossible, Ethan Hunt ride a motorcycle of a Norwegian cliff, okay, from a cliff, and he launching his motorcycle horizontally, but from here, from the height of 80 meter, and the combined mass of motorcycle and rider is 200 kg, and here we have to neglect air friction, right? And g is given 10 meter per second square, so we have to determine the speed of motorcycle just before touching the ground. So first see this GIF and see how the actual motion will happen. So motorcycle will start from here, in this way it will come on the ground, right? So you can solve this problem by two methods. One by projectile motion and second by work energy theorem. So actually as of now we are discussing work energy theorem. So I will approach this problem with work energy theorem. According to work energy theorem, work done on object will be equal to change in kinetic energy of the object, right? So work done, suppose W is equal to half m v square minus u square. Now see here, work done will be done by what? So here work done will be done by gravitational force. So how this Ethan will come? He will come in downward direction, right? Downward direction. And gravity also will apply force in downward direction. So work done and will apply in downward direction. So force is downward, how much? mg, and displacement will be also how much? h, in direction of force. So total work done will be how much? mg h is equal to half m v square minus u square, right? m will get cancelled out. G is given how much? 10, and height is given how much? 80 meter. That is equal to half v square. Suppose at the ground velocity will be speed will be v, and horizontal speed will be how much? At the top 30 meter per second, and vertical speed will be 0, right? So total u we can write how much? 30 square. Is it? Because only it has a speed 30 meter per second. So 30 square. So now we can write this one 8 into 10, 800. This 2 also will come this side. So 800 into 2 is equal to v square minus 900. So v square is equal to how much? 1600 plus 900. So v square is equal to 2500, and from here v is equal to under root 2500. So directly we can write 50 meter per second. Now why meter per second? Because all the quantity we have taken in SI unit, so obviously v also will come in SI unit. So with what speed this bike will hit the ground? With 50 meter per second. I hope you understood this question. Okay, now you can do one thing. You can pause the video, hide the solution, and try to solve by yourself. Okay, and still if you have some doubt, please ask in comment box. In next video I will explain the solution. Okay, now come to this new question. Okay, it's a very interesting question. After solving, we will show you the GIF of this question also, how the actually ball will move, or this mass will move. Here, a particle of mass m slide down on a smooth curved surface, okay, that end in vertical loop of radius r. We need to find minimum height from which it should start so that it just complete the loop and does not fall at highest point, okay. So for this purpose, we will consider this point as a reference point. Give name of this point O, and consider velocity at this point O is how much? V. Okay, so I'm going to zoom little bit this diagram. Yeah, so I can solve easily. Now this mass m has to move on this and it has to reach on maximum height, right? So when it will reach at maximum height, we have to understand what force will work on it. So at this point, if we'll draw the FBD, gravitational force will work in downward direction, mg. And suppose at highest point, if we'll consider zero speed, what will happen? The object will fall down, right? So what we have to do? We have to maintain some centrifugal force. That's why this mg can balance by centrifugal force. Why centrifugal? Because I'm assuming we are in reference frame of what? Moving reference frame means we are sitting on this mass m. So which force will work? Outward. Centrifugal force. Centrifugal force will be what? Suppose at this point its velocity is v1. So centrifugal force will be m v1 square by r, where r is radius of the object, right? And normal reaction will be where? Downwards. So for minimum velocity, here we can consider normal reaction is 0. So we can write m v1 square by r is equal to what? mg. So m will get cancelled out. From here we will get v1 square is equal to g into r, right? So at top we want minimum velocity square is how much? Is equal to gr. Now consider object is moving from O point to maximum height, right? So now for this we can write the equation, energy equation for this object. So kinetic energy at O point will be we consider velocity at this point is v. So kinetic energy is total energy, for because this is the reference point and reference point we considered height is 0. So total energy of the object or mass m at point O is how much? Half mv square. And this energy is going when the object is going at maximum height. This energy should be equal to this energy. And how much will be the height of this maximum point is 2ry, because from here to here is r, here to here is r. So total height it will achieve 2r. So change in potential energy will be how much? 2r m into g. Plus at this point kinetic energy will be how much? Half into m into v square is how much? G into r, because at this point v1 square is how much? Gr. So from here we can cancel out m, right? So we will get what? If we'll solve here, it will become 5rg by 2rg plus 1 by 2rg, that is 5 by 2 rg, and it will become 1 by 2 v square. So 2 we can cancel out, and here v square will become how much? 5r into g. So at this point its velocity speed should be 5r into g. Now how it will achieve this velocity? Speed v square is equal to 5rg. It will achieve due to work done by gravity. So when the object will fall from height h to this point, work done by gravity will be mgh, and this will be equal to kinetic energy at this point. So half m into v square, that is 5gr. m will get cancelled out, g will get cancelled out, and finally h will become how much? 5 into r. Clear? Understood? Okay. Now next slide we will discuss its motion, how actually the object will move. See, understood? So object will move like this, it will slide, and here it will complete the circle. At this point its speed will be minimum. Clear? And here mg is equal to what? Centrifugal force of the object, right? So at this point also we can say weight of the object will be how much? 0. Now we have to understand work energy theorem by variable force. So we will derive the expression. It will help you, this derivation, to solve question based on variable force. Okay. So here we can write, we consider an object of mass m. At any point its velocity is, speed is v. Okay. So kinetic energy will be how much? Half m v square. If we differentiate both sides with respect to t, we can write dke by dt is equal to d by dt of half mv square. So here we can write dke by dt is equal to half, and m is constant. Here we consider mass of the object is not changing with time. So we can write dv square by dt. Now differentiation of dv square by dt will be how much? We can write this is equal to half m v into 2 dv by dt, right? We can write. So 2 will get cancelled out. It will become m v dv by dt, and this is equal to what? dke by dt. Now, okay, students, we also know that dv by dt is equal to what? Acceleration a. Okay, so here we can write dke by dt is equal to m. dv by dt we can write a, so m into a into v. ma is equal to what? Force, and v is equal to what? ds by dt. So here we can write dke by dt is equal to force into ds by dt, right? ds by velocity is what? Rate of change of displacement. That's why we have written ds by dt. Now tt we can cancel out, and it will become dke is equal to f ds. Now if we'll integrate both sides, ke initial to ke final is equal to fds. Fds is what? Work done. So we can write, if we'll take the limit, ke final minus ke initial is equal to what? Integral of f ds, and that is equal to what? Work done, right? So this way we can write, or we can express the work done is equal to what? Change in kinetic energy of the object when force is variable, right? So this is integral. Okay, now solve one question based on this. Here given that a particle of mass 2 kg moving along x-axis under a position displacement position dependent force, where force is given in terms of x, 6 minus 2x plus 3x square, and initial condition is given what? At origin velocity is 0. So we have to find out velocity at 3 meter, right? So again we can write work done is equal to what? Force into ds, and obviously we have to integrate it. So here work done on the object is equal to 6. Force expression is given 6 minus 2x plus 3x square, and here displacement is given in terms of x. So at place of s we can write x. this one's dx. When we will integrate, we will get what? Work done is equal to 6x minus 2x square by 2 plus 3x cube by 3, right? And it's given that here integral limit is given what? 0 to 3. So here also we can take limit 0 to 3. So finally it will become what? 6x minus x square, this 2 we can cancel out, 3 we can cancel out, plus x cube, and limit will be 0 to 3. We can write further 6x, 6 into 3, work done is equal to 6 into 3, 18 minus 9 plus 27. This is equal to how much? 27 plus 9, it means 36 joule. Work done is equal to how much? 36 joule. And this will be equal to what? Change in kinetic energy. So 36 is equal to what? Half m into v square minus u square, and u is given how much? 0. So directly we can write 36 is equal to half into 2 into what? V square. So 2 half get cancel out. Here v will get what? 6 meter per second. Right? So here we will get what? 6 meter per second. So which option is correct? Option C is correct. Okay. Now do one thing. Take a pause, hide the solution and try to solve by yourself. If you are not able to solve, check the solution again. If you have some confusion, write down in comment box. I will solve question once again, or I will clarify your doubt in next video. Yeah, here in next question, force depend on time. So again, it's a variable force and we have to solve the question based on it. Now question, a superhero pushes a bike of 200 kg along a straight track. The force applied by superhero varies with time as 6t square plus 200 t Newton, where t is in second. Assume that bike move in direction of force and start from rest at t is equal to 0. Means the initial velocity at t is equal to 0 is how much? 0. Okay. Direction of force. Okay. The work done by the superhero we have to calculate in terms of t. Right? So now we will write here work done is equal to what? F dot ds, and this is equal to what? Change in kinetic energy, v square minus u square. Right? So here we will try to find out change in kinetic energy, and that will give us the value of work done. So in this question we will try to find out change in kinetic energy, because that will be easy for me. Okay, so here what force is given this much, so acceleration will be how much? Force by mass, because we know F is equal to ma. We already know F is equal to what? Ma. So a is equal to what? F by m. So acceleration will be force by mass. So here 600 t square plus 200 t divided by 200. So acceleration we will get what? 0 will cancel out and it will become 3t square, and this 200 will cancel out, plus t. Right? So it will become 3t square plus t. And acceleration, what we know? Rate of change of velocity is acceleration. So we can write dv by dt is equal to 3t square, dv by dt is equal to, yes, correct, 3t square plus t. So from here we will get dv is equal to what? 3t cube divided by 3. dv is equal to this one 3t square plus t dt. So direct I'm differentiating, sorry, integrating and writing here plus t square by 2. I hope you can understand. It's a nothing, it's an integral of this. So this will get cancelled out, and here dv we will get what? Here we can write this side integration of 0 to v dv is equal to t cube plus t square by 2. So if we'll integrate this side, it will become what? V is equal to t cube plus t square by 2, right? This is the value of V. And here we know that work done is equal to what? Change in kinetic energy, right? So change in kinetic energy is equal to how much? Change in kinetic energy is equal to half into m into v square minus u square, and u is given how much? 0 at initial condition, so it will become half into 200 into t cube plus t square by 2 whole square. This will get cancelled out, it will become 100. So the final change in kinetic energy is 100 t cube plus t square by 2 whole square joule, and this change in kinetic energy is equal to what? Work done on the object or work done on the bike. So students, I hope you understood this lecture very well, and what you want to learn next or what you want to understand next, please write down in comment box so I can make my next video according to that. Thank you everyone.